Hey students, today we're going to discuss the worksheet about diffusion. I posted 2 videos of diffusion last time for your review, for your revision, and so that you should know that how does it work, how to understand diffusion, what is it, and how diffusion happens in liquids, gases, and why diffusion does not happen in solids. And the diffusion relation with the molecular mass of a substance. So if a gas or liquid particles are heavier, they diffuse slow. And if the particles are light, they diffuse faster. So let's do some of the paper 2 questions, which are MCQs related to the topic of diffusion. Okay, so this is the first question. The first question is 2 gas jars are set up as shown. As you can see in the diagram, in the first, these 2 gas jars, there is a lid in the middle. So there's a brown gas in the second jar. And after the lid is removed, then both of the jars get filled with brown color. The lid is removed and the gas jars are left to stand. After some time, the contents of both gas jars are brown. Which process causes this to happen? Very easy. This is diffusion. Because of diffusion, the particles spread and they move from high to low concentration. Then we have question number 2. Question number 2 is we have a glass tube which is closed from both ends, and on the one end we have a cotton wool soaked in hydrochloric acid, HCl, and on the other side we have a cotton wool which is dipped in ammonia, NH3. Which statement explains why the ring of ammonium chloride appears as shown? So as you can see in the diagram, that ammonium chloride is forming near to hydrochloric acid and it's far from ammonia. This experiment is very important as it is present in many questions. They have asked you about this thing. That why this product is forming near hydrochloric acid, and it has a very simple explanation. Because hydrochloric acid particles, they move slow and ammonia particles move faster, so they travel this much distance in that given time, and hydrochloric acid covers this much distance, less distance in the same time. This is because ammonia particles are lighter in mass and HCl particles are heavier in mass. Now, the thing is, how do we know? We know it by calculating their molecular mass. We have to find out the molecular mass of 2 substances. Like we have HCl. For HCl, we have 1 for hydrogen, and chlorine's atomic mass is 35.5, which makes it 36.5 for HCl. And as for the ammonia, NH3, nitrogen is 17 and hydrogen is 1 multiplied by 3, because 1 is the atomic mass of hydrogen multiplied by 3 is the atomic number. Nitrogen is 14. So 14 plus 3, which makes it total 17. So ammonia mass is 17. One particle of ammonia has a mass 17, and 1 particle of HCl, 1 molecule of HCl, has a mass 36.5, which is almost the double of it. So as you can see, that hydrochloric acid particles are much bigger, so they are heavier. They will move slow, as compared to if the ammonia particles are small, light in mass, so they move faster. Now, which statement explains why the ring of ammonium chloride appears as shown? Ammonia solution only produces a gas. Only ammonia solution produces a gas which moves until it meets the hydrochloric acid? No. Both solutions produce a gas, but ammonia moves quicker than hydrogen chloride because it is lighter. It might be true. Let's see. Hydrochloric acid produces hydrogen chloride which stays at one end of the tube until ammonia reaches it. No. The 2 solutions run along the tube until they meet. No, this one is correct. The ring is forming because at that point, ring is forming because ammonia particles move faster and hydrogen chloride particles are slow. Okay, next question is, the particles moving very slowly from high concentration to low concentration, which process is being described? Okay, so from high to low concentration, this is called, yes, students? Yes, you are right. This is called diffusion. The movement of particles from high to low concentration. And diffusion does not occur in solid. Okay, so solid will cancel it. Okay, the liquid being frozen. Again, solidification. There is no diffusion in solidification when it is frozen. So these two, substance diffusing through a liquid and substance diffusing through the air. Now, air is a mixture of gases, liquid and gas. Very slowly, diffusion is slower in liquids as compared to gas because gas particles move faster and liquid particles are much slower as compared to gas particles. Okay, then we have the next question. The gas is released at point Q. Okay, this is point Q and the gas is released at this point. Then we have a universal indicator paper, damped universal indicator paper. Which gas changes the color of the damped universal indicator paper most quickly? Means which is the fastest? So obviously the fastest will be the gas whose molecular mass, whose MR is least. The slowest molecular, the smallest molecular mass. So as you can see here, the smallest molecular mass is of hydrogen. Okay, but hydrogen will not change the color of universal indicator as it is neutral. It is a neutral gas. So it won't change the color of universal indicator. So you have to mind it. Although hydrogen has the least mass, but it will not change the color of universal indicator paper. That's why hydrogen is not correct. Ammonia, on the other hand, it will change the universal indicator color to blue as it is a weak alkali. It's a alkaline gas. It's a weakly basic gas. So that's why ammonia will change the color and it has the least molecular mass as compared to carbon dioxide and chlorine. Hydrogen will not change the color. It's a neutral gas. So that's why we are not correcting it. We will not consider it. Okay. Question number 5 is also similar to what we have done before. That we have a glass tube. After a few minutes, solid ammonium chloride forms where the two gases meet. So here at this place, solid ammonium chloride, the product is forming. So we have ammonia and hydrogen chloride gas. We saw before that ammonia mass is 17 and hydrogen chloride mass is 36.5. Now, the experiment is repeated using hydrogen bromide, HBr, in place of hydrogen chloride. How far long the tube does this the solid ammonium bromide form? Okay, so for the ammonium bromide, where will it form? Now, instead of hydrogen chloride, now we are using hydrogen bromide gas. Ammonia is the same, so it has a less mass, so obviously it will move faster. Right, it will move the faster. But the solid, will it form here or here? Okay, the solid will not form near to ammonia because it is less in mass. Hydrogen bromide will be more in mass. Hydrogen chloride is also more in mass, so the solid is forming here. Hydrogen chloride particles are heavier, they move slow. And ammonia particles are moving faster, so the product is forming at this point, which is B. Now, hydrogen bromide is much more heavier than hydrogen chloride because it has bromine. It is HBr. So hydrogen is 1 and bromine is almost 80, 79.5. Right. So its answer will be 81 or 80.5, which means it is double in mass as compared to hydrogen chloride. Okay, so its particles will be heavier than hydrogen chloride. They're much more heavier than hydrogen chloride. So the product will form at A. So A is the correct answer because the particles of hydrogen bromide will move much more slower as compared to hydrogen chloride. So they will just move a little bit distance and ammonia particles zoom very quickly. They will cover the distance very quickly and they both will meet here and form the product at A. I hope you get it. Then question number 6, very easy. Hydrogen and fluorine are gaseous elements next to each other in the periodic table. Under the same conditions of temperature and pressure, oxygen diffuses dash than fluorine because its dash is less than that of fluorine. Okay, so in the periodic table, oxygen and fluorine are neighbors next to each other. Oxygen is present in group number 6 and fluorine is present in group number 7, which makes fluorine mass more than oxygen. So oxygen is light. Oxygen diffuses the fastest. It will diffuse faster than fluorine because its molecular mass is less than fluorine. So it will move the faster. Oxygen will diffuse faster because its molecular mass is less than that of fluorine. That's why it will diffuse faster. Then we have question number 7. Student investigated the diffusion of ammonia gas and hydrogen chloride gas. Same question. In ammonia gas, we have damp red litmus paper and hydrogen chloride gas, damp blue litmus paper. Right. Now, because ammonia, as I told you, that ammonia is a weakly alkaline gas. So it will change the universal indicator, red universal indicator paper into blue. And hydrogen chloride gas is acidic. So it will turn the blue litmus paper into red. The damp red litmus paper in apparatus 1 changed color after 30 seconds. Right. So ammonia is changing the color of universal indicator in just 30 seconds, half of the minute. How long does it take for the damp blue litmus paper to change the color in apparatus 2? Right. Hydrogen chloride particles are heavier than ammonia. They move much slower. So obviously they will take more than 30 seconds. So the answer is 64. They will take more time. Question number 8. Samples of 4 gases are released in a room. So we have 4 gases over here. The question is, which gas will diffuse the fastest? So carbon dioxide, CO2, we have HCl, we have H2S, and we have nitrogen dioxide, NO2. So for CO2, carbon is 12, oxygen is 16 into 2, which makes carbon dioxide 44. Hydrogen is 1, chlorine is 35.5, which makes HCl 36.5. Hydrogen, where there are 2 atoms of hydrogen, so 1 into 2, and sulfur is 32, which makes hydrogen sulfide mass 34. And as for the nitrogen dioxide, nitrogen is 14 plus oxygen 16 into 2. 14 plus 32, which makes the mass 46. So which gas will diffuse the fastest? The one which is the smallest, the one which has the least atomic number, least atomic mass, least molecular mass. So the least molecular mass is of H2S. So the answer is hydrogen sulfide. Next, the rate of diffusion of gas depends on its molecular mass and the temperature. The combination of molecular mass and temperature gives the slowest rate of diffusion. So the rate of diffusion will be slow if the molecular mass is high and if the temperature is low. Yeah, because diffusion is inversely proportional to, it's directly proportional to temperature. Yeah. It's directly proportional to temperature. As the temperature is more, the movement of particles will also be more. And if the temperature is less, the movement of particles is also less. So if we want the particles to move slow rate of diffusion, so we have to decrease the temperature and the mass of the particle should be high. It should be really fat to make it move slowly. Then question number 10. Which 2 gases will diffuse at the same rate at the same temperature? Now, at the same rate, we have to see means same speed. Which two gases will move at the same speed? It means which two gases have the same mass. If we take out carbon monoxide is CO, its mass is 12 plus 16, 28. Carbon dioxide we just took out above, it's 44. Carbon monoxide again 28. Nitrogen is N2. Nitrogen 14 into 2, which makes it 28. So you get the answer. This is B. Carbon monoxide, nitrogen molecule. They both have the masses 28, 28, 28. So it means they will diffuse at the same rate. Then we have the last page. The formula of methane is CH4. The formula of ethane is C2H6. Which row describes diffusion and the relative rates of diffusion of methane and ethane? It's very clear from the formula that ethane's mass will be more because it is C2H6, and methane mass will be less. It has only one carbon while ethane has two carbons. Methane has 4 hydrogens while ethane has 6 hydrogens. So it's obvious ethane has more mass, methane has less mass. So the answer will be that first of all we'll see the diffusion, that which particles will diffuse. Particles move from high to low concentration. Yeah. Particles move from high to low concentration. Yeah. Particles from low to high, particles from low to high. These two are wrong. And if we see here the description, relative rate of diffusion, ethane diffuses more quickly than methane. Methane diffuses more quickly, yes, because methane's mass is less, so it will diffuse more quickly than ethane. B is the answer. Number 12 and 13. When a dark gray solid element is heated, it changes directly into a purple gas. Which word describes this change? Solid changing into gas. No, guys, this is not diffusion. There's no diffusion in the option. Also, solid changing into gas is not a diffusion. It's just phase change, which is sublimation. Which gas has the fastest rate of diffusion? Fastest rate of diffusion will be the lightest mass of the lightest one. And obviously, this is hydrogen because hydrogen has a mass of 2. Methane mass is 16. Carbon dioxide mass is 44. And sulfur dioxide mass is, sulfur is 32. Oxygen is 16 into 2. 32 plus 32, which makes the mass 64. So the least mass is of hydrogen, so its particles will diffuse the fastest. So here you go, guys. This was the worksheet and some of the past paper questions, paper 2 questions related to diffusion, the rate of diffusion and how it depends upon the molecular mass, temperature, and everything. Hope you get these questions, and later on I'll be uploading some of the paper 4 questions of diffusion, and you will get to know how paper 4 questions will come related to diffusion. Thank you so much for watching and keep following me for more videos like this.